Hello, thanks for checking out my channel today. Today I'm going to talk about these PS2 keyboard hosts that I built. So if you checked out my video, I posted, I think it's the one right before this, I demonstrated prototyping this. So this is the finished product here. It uses the W83C42P keyboard controller. This came about in the 90s, I want to say. In the datasheet, it talks about how it's designed from a hardware level to run the keyboard, where the 8042 ran at a software level. So this does take a lot of the same commands as the 8042, and it works effectively the same way, and it claims it runs faster. So whatever that's supposed to mean for like internally, it's saying better response times, I think is what they were getting at in the data sheet. So got the support chips here, just a hex inverter and a hex buffer, and then the 12 megahertz clock. I think it can go as low as a 6. I'm just keeping with a 12. It works just fine. Got a couple resistors to keep noise off the keyboard lines, and our PS2 socket there. Interrupt pin right here. Or this is the interrupt. It's a jumper. The interrupt pin's on the header there. This selects if you want to go high or low, depending on the application of your project. An 8088, the 8259 interrupt controller wants it to be high. So you would put that on the high side. Right now I've got it on the low side, and there's a reason for that. So I'm plugging this into my project, and the project was designed to be used with this USB host. This has a low interrupt, and so my board was designed to accept a low. So on my motherboard, even though the interrupt controller wants high, I run that through a hex inverter and it goes low. So for my motherboard, we select low. This should work on pretty much any application, like an 8-bit processor application. So the Z80, the was the 6502, the 8088, the 8086, it should all work just fine on any of those projects. I'm going to test soon, and maybe I'll make a video on it, of running this with like an Arduino, a microcontroller. I'm just not sure if there's like a minimum or maximum read time, because those pins obviously go a lot slower than a system bus, and this is designed to plug right into the system bus without any buffers. So yeah, we'll see if it works with the microcontroller, but I'll do that another day. The pin header here, your data pins are along the left side here. You got your write, read, chip select, address 2, interrupt, a 5 volt and ground. And just because that says address 2, you could put address 0 there. It just selects between the command register and the data register, really. And going back to this, that it's an identical pin header to this USB host. So where this connects into my project, you can see we just use a ribbon cable, just like the hard drive here, which is on the USB host. And I've got this plugged into the port 60 there. Sorry, I got a wire that just popped up there. Want this to be able to boot when we do our demo. So right there, it's complete. One thing is, I guess if you put this into a case at this point, you're going to have this kind of flopping around. So maybe one day I'll put this on the board itself, but I'm still having faith that I can go with a USB controller one day. So I'm going to kind of hold off on that. For now, I think this is kind of at a finished state. I'm going to leave it alone for a few months, maybe even a couple years. But eventually, maybe I'll even do a whole different design where I do an actual motherboard with some ISA slots on it, and I'll embed this right onto the board. But let me give you a demo. Let me, while it's booting up, I'll talk to you about the code. You can see it's just going to boot DOS, and then we'll demonstrate the keyboard. So the code's really straightforward to initialize this. And that's what's so handy about this is all I have to do is write 60 to the command port, which is on this board 64. And then on the data port, I write 21, which is port 60. And that 21, I think the 1 is for the enable interrupts, and then the 2 selects the mode. So it's like there's like PC mode or PC compatible mode. I'll have to read up and see what the actual difference is. I don't think it gives any different scan codes. I'm not sure. I'll have to look into that. So that's all you have to do if you put this like on your Z80 or your other projects. That's how you initialize it. Without sending these commands, it doesn't operate. Just so you can be aware of that. So here we are, we're at the DOS prompt. Push some keys, so you can see the keys are working. I got my keyboard down here. And the advantage to this keyboard controller is, as being an actual keyboard controller, it works 100% PC compatible. Like, you'll be able to turn the LEDs, so when you push caps lock, I'm holding caps lock now, the LED on the keyboard, you can turn it on and off, the num lock. Also shift, so I'm holding the shift, I just pushed D, I left up on shift. You can see there's like a 92 on that third line. That was me letting up. So you can interpret this in your BIOS and actually have a real full-blown keyboard. So that's kind of the demo there. Keep watching. I'm going to probably do a full demo on the board, because I've done a lot of pieced videos like this where it's one part or the other. Next couple days, it'll be a longer video, but I'll talk about the whole project as a whole. So stay tuned in, watching out for that video coming up in a couple of days. So thanks for checking out this PS2 video today.